Hello student, here we discuss about Mutarotation in carbohydrate. I'm Meena Dikshit. If you like my video, please subscribe my channel. Here we will discuss what is Mutarotation and explain with taking example with the help of Fischer projection. A spontaneous change in the specific rotation of a solution of an optically active compound is called mutarotation. What does it mean? Means this is alpha D glucose and this is beta D glucose. Angle of rotation here 18.7, here 112 degree. Okay, so in equilibrium we see that D glucose they are the beta D glucose and alpha D glucose, they are stable in solid state, but in aqueous medium they are interconvertible. See here, and angle is 18.7, it is converted into this D glucose and then angle changes to 112 degree when it is converted into alpha D. Okay, like that alpha D converted to glucose and then angle is 18.7. This interconversion takes place and this is the hemiacetal form of the glucose. Glucose here anomeric, this is anomeric carbon. When it is called anomeric carbon, when this carbonyl group cyclizes and form hemiacetal and giving rise to this alpha and beta isomers. So these are actually also called anomers. Okay, so these are called anomers. So here spontaneous change you have seen that in aqueous medium 112 degree angle changes to 18.7. When it is alpha converted into beta, beta converted to alpha, angle will change, and this spontaneous change is called mutarotation. Okay, so hemiacetal form of alpha glucose and hemiacetal form of D fructose 11th and 12th, this is on the course. Okay, are stable in solid state, but in aqueous medium they are there is opening a in aqueous medium cyclic structure open up. This is cyclic structure in solid state, but in aqueous medium the cyclic structure open up, and all these three are in equilibrium. Clear? In solid state separately they are stable, in aqueous medium they open the ring and they will exist in this carbonyl group is free now, and it will give all the test of CHO group. Okay, so this carbon, which is earlier it was carbonyl group, this is carbonyl group, when cyclizes it will become chiral carbon. In here it is not chiral carbon, but when it cyclizes and it form hemiacetal, at that time it is anomeric. This anomeric carbon is, what is it? It is optically active. This is Fischer projection. Draw this structure. Okay, an anomeric carbon, C1 carbon. In case of alpha glucose, this glucose, when glucose cyclizes, it will form alpha. First carbon is alpha carbon. And fructose, it is C2 carbon. Okay, now this is Haworth projection. Write down Haworth projection also. Draw this structure. See, this is C1 carbon. Here earlier we have seen that it was CHO group. Okay, here it was CHO group. Where it is gone? Here it was CHO group. Right, now in Fischer projection I have shown you open chain structure, but here I have shown it in the cyclic form. Okay, so alpha D and beta D, this is written in the class 12th chemistry book. Okay, so mutarotation is a spontaneous change in the optical rotation of a solution. Over time interconversion takes place. Mutarotation is caused by interconversion of anomers in the equilibrium process. This phenomena always possible in carbohydrates. Okay, or then the adjust between alpha and beta form is there, as well as open chain structure will be there. Here earlier I told you open chain, so I am not showing you this is open chain. We can draw like this. This is in Fischer projection, this is Haworth projection. Any type of projection they can ask for you. Okay, now mutarotation is caused by the interconversion of anomers in the equilibrium process, and then this phenomena is most common in carbohydrates such as glucose, which exists in aqueous solution as mixture of alpha and beta glucose anomers. See, alpha and beta glucose both are present in aqueous medium along with open chain. Okay, so in equilibrium two form alpha and beta forms are existing. Okay, in the solution. So anomers leading to dynamic change in the specific rotation of plane of polarized light until stable equilibrium is reached. What does it mean? It means see angle here 112, here plus 18.7, and dynamic equilibrium both the angle will remain the equal. Okay, then we call it dynamic equilibrium, right? Now write down the angle also. And the anomeric carbon is C1 and C1 carbon in glucose and C2 carbon in fructose. Cyclic form was originally the carbonyl carbon in the open chain form. This carbon becomes a new chiral center when the sugar cyclizes. So this is known as anomers. C1 carbon or C1 carbon in glucose and C2 carbon in fructose is known as anomers. And we'll get two forms, alpha and beta. They are in equilibrium in aqueous medium. Thank you for watching. All the best.